Picture this. A weapon so incredibly powerful it could sterilize an entire planet from thousands of light years away. It fires a silent, invisible beam that rips through space at the speed of light. That means you'd have absolutely zero warning before it strikes. And here's the wild part. This isn't some far-fetched sci-fi fantasy. Somewhere out there in the vast, dark cosmos, this death ray really exists, and we call it a gamma-ray burst. The chilling question is, could one already be screaming its way towards Earth right now? Seriously, in less time than it takes you to even blink, a burst of radiation packing more raw energy than our sun will produce in its entire lifetime could hit our atmosphere and shred the ozone like tissue paper. The kicker? We'd never see it coming. So how did we even find these things? Believe it or not, it all started during the height of the Cold War. The US launched satellites, parking them high above Earth, specifically to sniff out clandestine Soviet nuclear tests. Instead, their instruments recorded quick spikes of gamma energy, and they were clearly coming from deep, deep space. Analysts initially thought the sensors were just glitching out. But as these mysterious flashes kept appearing, time and time again, astronomers realized they'd stumbled onto something vastly, unbelievably more violent than any hydrogen bomb. Okay, so what are these things? Gamma rays are essentially just photons, like the light you're seeing right now, but each one carries an insane something vastly, unbelievably more violent than any hydrogen bomb. They sit at the absolute far end of the electromagnetic spectrum, way past X-rays. And here's the terrifying bit. They're ionizing. What does that mean in plain English? It means when a single gamma ray rips through your DNA, it leaves that delicate molecule looking like Swiss cheese. Sure, one tiny photon won't kill you, but a full-on flood of them? That would systematically dismantle every single biochemical process life depends on. Poof. Gone. Now, where do these things even come from? We've got two main types. The long bursts, lasting over 2 seconds, are birthed from the cataclysmic death of truly colossal stars, 30+ times the mass of our sun. When such a star finally runs out of fuel, its core can't support itself anymore and collapses inwards, forming a brand new black hole. As the core vanishes, the star's outer layers rebound with unbelievable force in what we call a hypernova. Material swirls around that nascent black hole so violently that it forms an accretion disk, which then channels incredibly powerful twin jets of plasma. These jets punch out at an insane 99.999% the speed of light, drilling a path straight through space and focusing those deadly gamma rays into a super narrow, laser-like beam. It's like a cosmic railgun. Then you've got the short bursts, which are usually under 2 seconds. These are even crazier in some ways. They happen when two super-dense cosmic titans, like two neutron stars, or even a neutron star in a black hole, get caught in a gravitational dance. They spiral closer and closer, faster and faster, until they violently merge. This collision is so incredibly energetic that it also produces a similar laser-like flash of gamma rays. Either way you slice it, you're looking at nature's ultimate celestial sniper shot. We've actually had a taste of this power, even from afar. Back in 2022, the brightest burst ever recorded, GRB 221009A, walloped Earth from a mind-boggling 2 billion light-years away. That distance is so absurd the pulse should have been completely harmless. Yet, it still disturbed our ionosphere, set off lightning detectors across the globe, and even warped long-wave radio communications for hours. This single event released roughly the same energy as several hundred supernovae, yet it lasted less than a minute. If something like that detonated inside our own galaxy, and if that focused beam just happened to intersect Earth, well, let's just say we'd be swapping places with the dinosaurs in a cosmic instant. So what would a direct hit actually do? The gamma flash itself wouldn't instantly roast the surface. Instead, it would slam into our upper atmosphere, viciously shredding ozone molecules. Within mere minutes, unfiltered, Deadly ultraviolet light from the sun would pour through those newly formed gaps, absolutely frying plankton in the oceans, collapsing entire food chains, and likely triggering global wildfires. And it gets worse. The interaction would create massive amounts of nitric and nitrous oxides, which would quickly gray the sky and plunge the planet into a deep, sustained cooling period. Plants would die off, herbivores would starve, and carnivores would inevitably follow. A nearby burst like this could realistically wipe out roughly a quarter of Earth's biodiversity, mirroring what happened 445 million years ago during the Ordovician extinction, an event some researchers are now chillingly linking to a past gamma-ray hit. Alright, so are we all going to die tomorrow? Probably not. Here's the good news. Those beams are incredibly narrow, usually just a few degrees across. That means Earth has to be sitting directly in the crosshairs, like hitting a bullseye with a cosmic dart. Statistically speaking, a burst powerful enough to actually matter, one originating within a danger bubble of about 200 light-years around us, happens in the Milky Way maybe once every million years. Our current neighborhood, our little corner of the galaxy, is actually pretty quiet right now. No massive star angled precisely toward us appears ready to pop. Now for the bad news, because gamma rays travel at the speed of light, we would get absolutely zero heads up. 1 second, the sky looks perfectly normal, and the next, the ionosphere lights up like a neon tube. So are we doomed? Probably not today, probably not tomorrow. But the universe keeps its own wild schedule. Somewhere, right this very second, a star is burning through the last vestiges of its fuel, its core ticking down to an inevitable, violent detonation, its deadly jets already aimed at where Earth will be in 10,000 years. Gamma-ray bursts are this incredible, terrifying reminder that we live on a fragile little island in an ocean that occasionally throws truly rogue waves. We can't stop them, can't outrun them, yet understanding them turns terror into wonder, and maybe that's enough. If this insane blend of cosmic awe and mild existential dread is totally your thing, then you absolutely have to hit that subscribe button right now. And seriously, dive into the playlist linked below for even more mind-bending cosmic catastrophes. Oh, and here's a question for you. Let me know in the comments, would you want to know the day before I'm genuinely curious.